the run-up to the Russian invasion of Ukraine, we saw the satellite bandwidth on key Russian satellites go up by a factor of 3. What was happening is as Russian forces prepared to move west, they were provisioning their satellite communications and moving those to satellites that were covering the Western Front as well. This is an example of how looking at satellite bandwidth and the patterns in that can really be an indicator of adversary intent, serve as early indications and warnings. The power of the KnownSpace network and the passive RF technology it uses is that we are continuously collecting on satellites. Whether it's raining or snowing, or it's daytime or nighttime, our sensors are able to uniquely pick out the signals that satellites are transmitting. Electro-optical and radar sensors are really good for tracking debris, but when it comes to these rendezvous and proximity situations, you need something that's persistent. We can figure out not just where the satellites are, but actually what they're doing based on their pattern of life and some of the signal characterization work that we can do. It's truly a network designed for modern space operations.
The Kratos Global Sensor Network is a worldwide infrastructure of RF sensors.
21 sites around the globe. There's 190 apertures that sit at mostly commercial teleports. We use it for passive ranging or the tracking of the systems, the EMI, the electromagnetic interference monitoring, the geolocation activity, and the signal survey and characterization.
And our key value is that we provide not just data, but the actual information and answer to important questions. Questions like not only where is a satellite, but what is it doing? Who on the ground is using it? How are they using it? How is their usage changing? And most importantly, why does it matter?
We've worked with a number of customers, both on the commercial side and on the federal side, to build a ground station from top to bottom as a complete turnkey capability. Here in Colorado, we have a network operations center.
The Kratos Network Operations Center is a 24/7 facility, and we tend to hire people who are very passionate about the mission. Those people are true RF experts. When our customers tour our operations center, they're often very surprised at what we're able to do at the pure commercial level. Often what they're seeing is data that they've only seen before in classified or government-operated environments.
Russia flies a fleet of satellites known as Luch. They are publicly advertised as a tracking and data relay satellite. They're supposed to sit in the geosynchronous belt. Instead of sitting in one place, acting as a relay station, instead they're constantly changing their position in that geobelt, and they get very, very, very close to other communications payloads.
And so many speculate that the reason the Russians want to get so close is so they can observe that SATCOM and understand how it's being used. It's no coincidence that in the run-up to the Ukrainian crisis, Luch moved very close to satellites that were supporting EUCOM, US, and allied forces. The Ukrainian conflict has shown us several trends that are emerging in modern warfare. We're seeing intentional jamming on a scale that's really unprecedented.
We've been monitoring a spacecraft known as SJ-21. This is a satellite that is owned by China, and it is publicly listed as a debris removal spacecraft. So this spacecraft actually has equipment on it so that it can grab debris. In the case of SJ-21, we can see if it's being used for its appropriate purpose or not.
SpaceX and Starlink have launched already thousands of satellites into low Earth orbit.
Both the military and commercial providers are tracking those with radar. But when they deploy, from a radar perspective, they all look the same. How do you know which one is which? From a radar perspective, you can't tell. From an optical perspective, you can't tell. But with passive RF, we're able to uniquely identify that signature and be able to help fuse with that radar data. And so now you can start to uniquely identify and characterize these vehicles in these big launches. Understanding the RF environment and where it's being used, how it's being used, is going to become a global issue, and understand what's going on from a regulation perspective.
The RF environment and space in general continues to change. Another big change is 5G, non-terrestrial 5G networks. We are ready for whatever the next challenges are.